Okay, so this is going to be the second set of example problems for Charles' Law. Okay, so our first example for today. The temperature inside my refrigerator is about 4 degrees Celsius. If I place a balloon in my fridge that initially has a temperature of 22 degrees Celsius and a volume of 0.5 liters, what will be the volume of the balloon when it is fully cooled by the refrigerator? Okay, so the temperature inside my refrigerator is about 4 degrees Celsius. If I place a balloon in my fridge that initially has a temperature of 22 degrees Celsius and a volume of 0.5 liters, what will be the volume of the balloon when it is fully cooled? Okay, so just like we did in our last lesson, we have to make sure we convert all our temperatures to Celsius. The Celsius temperatures to Kelvin. So our first one, 4 degrees Celsius. So Kelvin is going to be 4 degrees Celsius plus 273. And we get 277 K. My second temperature that we're going to be dealing with is 22 degrees Celsius. We're going to add 273 to that. So 22 plus 273 comes out to be 295 K. Okay, so we're going to use our formula for Charles' Law. V1 over T1 is equal to V2 over T2, because we're dealing with volumes and temperatures in this question. Okay, my initial volume and my initial temperature are these conditions right here. It's going to be 0.5. T1 is 22, so we're going to use the 295. We want to know what the volume is whenever it's fully cooled down to 4 degrees Celsius. So your 4 degrees Celsius is 277 K. Now when we do this, we're going to cross multiply and divide by 295. And you get 0.469 liters. Okay, next example. Okay, it says a man heats a balloon in an oven. Okay, the balloon initially has a volume of 0.4 liters and a temperature of 20 degrees Celsius. what will the volume of the balloon be after he heats it to 250 degrees Celsius? Okay, so we're dealing with volumes and temperatures in this question, so we're going to use Charles' law. So it's V1 over T1 is equal to V2 over T2. Now we got to convert any of our temperatures to Kelvin. So we're going to do 20 plus 273. Comes out to be 293. And then we're going to do 250 plus 273. Put that in the calculator. Is 523. Okay. Now, we're going to plug into our formula. V1 is 0.4. And your initial temperature is 20 degrees Celsius, so we'll put a 293 in there. V2 is what we're looking for, and 523 is our second temperature. Now what we're going to do is we're going to cross multiply and divide. 0.4 times 523 divided by 293 should give us 0.713 liters. Okay, last question. This video. A sample of oxygen at 300 kPa has a volume of 200 milliliters. What is the volume of the gas when the pressure is increased to 450 kilopascals? Okay, so we're dealing with pressure and volume in this question. So since we're dealing with pressure and volume, we're going to use Boyle's law. So from last lesson, Boyle's law is P1V1 is equal to P2V2. Our pressure is 300 kPa. Our volume is 200. P2 is going to be 450. And we're looking for V2. So we're going to multiply 300 times 200 and divide by 450. So V2 comes out to be 133.33, and we're in milliliters. Now, just a heads up on some of these problems that you're going to be dealing with in the next couple of homework sets or so. STP means 1 atmosphere pressure, 0 degrees Celsius, or 273 Kelvin. What else was there? If it says constant temperature, that means the temperature is not changing. If it says constant pressure, that means that the pressure is not changing. So just keep those things in mind as we're doing these problems. Oh, if it says it increases by 20 degrees or it decreases by 20 degrees, that means you're going to subtract or add, 20 degrees to each of the temperatures, for your final conditions and your initial conditions. So just keep that in mind as you're working through these worksheets that I'm going to be giving you. Hopefully you'll have a good day and you understood this. If you have any questions, feel free to reach out.